Oh, sorry. I didn't realize I was making a video here. Sorry. Forgot about that. Yeah, you know, just working out my muscles, working out my mind, all those things, getting ready for lesson 24, section 3. That's what we're doing right now. 24.3, which is continuing our study of the Pythagorean theorem. Only today we're going to use some 3D figures, see how we can apply it in 3D figures. So it's some more application of that Pythagorean theorem. Our learning target today is to model 3D figure problems using the right triangles and solve using the Pythagorean theorem. And a couple important things here. One is that if you look at the success criteria here, again, the Pythagorean theorem only works for right triangles, only right triangles. It doesn't work for any other type of triangles. And the Pythagorean theorem here is a squared plus b squared equals c squared. Just remember that C is the one that matters the most because it's by itself and it's the longest side of the triangle. So it's always opposite of the right angle. And we're going to create models and kind of work through that to use and solve the Pythagorean theorem. So today, I want to start here with the problem of the day. Let's read it through here. It says, how can you find the length of a diagonal line drawn from point A to point B in this rectangular prism? And again, if you look at this rectangular prism and try to picture it, it's 3D. The A is in the front and the B is in the back. So that's where, let me use a different color here, but that's where it's a little hard to picture, and it's a little bit different because it's cutting through that 3D figure. So we want to break it down a couple different ways, but if you picture it, it goes all the way through there. The only way you can make a right triangle out of this to find that thing would be as if you made a line going across the base of this too, and then up here. So we have that, and then the dotted line is the third side of our right triangle. Hopefully you can visualize that a little bit. The only problem with that is we have this height is 12, but we don't even know what this side length is. And we don't know this. So the Pythagorean theorem works if you have at least 2 side lengths, but we only have 1. So we're going to have to do something to find one of them in order to find the other one. So it's actually broken down really nicely in the book for us, and we're going to discuss it a little bit. So on page 214 and 215 in your notes book, that's where you can find this. I'd like you to follow along and take some notes. So what I said when it was broken down, and this actually takes apart exactly what I was trying to show there and just kind of pulls those triangles out. So for instance, the big triangle with that diagonal length is pulled out right here. And that's where we don't know the bottom. We have the 12, and we're trying to find, ultimately, we're trying to find that E. And then thinking about how to find that bottom or that C going across right here, there's also another triangle that's pulled out. It would be this one right here, the 3 and the 4 and the C. It would make a right triangle, right? Because that's a rectangular prism, so the bottom has to be a rectangle. So we can use the Pythagorean theorem to find that C, and then we can use it to find the E. Okay, so let's break that down. On page 215 here, first question, in the triangle with sides 3, 4, and C, which angle is the right angle? So if you look at it, it would be the angle across from side C, or the angle formed by the side lengths of 3 and 4. Because if you take those 2 side lengths and you make that angle, it's got to be a right angle because that base shape is a rectangle, part of a rectangular prism. That's how we know. Okay. Now, number 8, how does finding the length C help you find the diagonal E? And that's kind of what I just discussed. Okay. Side C is the hypotenuse of the smaller triangle, but it's also one of the legs of the bigger triangle that we're trying to ultimately find E. So I'm gonna write that in there just like that. The Side C is the hypotenuse of the smaller triangle, but it is also the one of the legs of the larger triangle that has side E in it. And we're ultimately trying to find side E. All right, so number 9, it says use the Pythagorean theorem to find the length of C and show your work. So you have a little bit more room off to the side than what I have here, but I'd like you to do that. It was given for us at the bottom of page 214, where we had 3 squared plus 4 squared equals C squared. Now, hopefully, maybe you remember, we've actually done this one before. It's a Pythagorean triple. It's one of the most common Pythagorean triples that people actually recognize. But we're going to check it out just to make sure. So 3 squared is 9. 4 squared, or 4 times 4 is 16. And those two add together to be 25. So 25 has to equal C squared. And last step to find C is to take the square root of both sides, because that'll give us C by itself. Square root of 25 is 5. So C equals 5. Okay? And that's a Pythagorean triple, 3, 4, 5. So maybe you just recognize that and you knew it was going to be 5. Okay. Now remember, it's C squared, or A squared plus B squared equals C squared, not A plus B equals C. So that's a different thing there. All right. Now it says use the Pythagorean theorem to find the lengths of E. So now that we have C, if we go back and look at this triangle, we know this is 5. So now we have 5 and 12, so we can say 5 squared, because these are both legs. Again, we know that this is E is the hypotenuse because it's across from the right angle too. Okay, so 5 squared plus 12 squared equals, we're looking for E, you could say C, but it's labeled as E squared here. And this is for number 10 we're doing. I'm just showing it here. It's a little bit more space for me. 25, I know 5 squared is 25. 12 squared, or 12 times 12 is 144. 144 plus 25. Maybe you got that already faster than me. That's fine. 169. So we have that equal to E squared, and we can take the square root, which, if you don't know the square root of 169, take a calculator, find the square root of it. It ends up equaling 13. So for number 10, we get E is equal to 13. So that's ultimately what we were trying to find in this one. But it took 2 steps. We had to use the Pythagorean theorem twice, and that's all right. So number 11 says, explain how to find the length of the diagonal in a right rectangular prism when you know the dimensions of the prism, like we did. So essentially is, we are going to explain what we just did. So you need to find the diagonal of one of the faces first. Then you can use it as one of the legs of our second triangle. All right, number 12, explain how you can use substitution to write just one equation for length E when you know the length and the width of the prism A and B and its height D. So this is where it gets a little bit tricky. Since we said originally that in that first triangle, A squared plus B squared, which we had 3 and 4, equals C squared. And if you want to solve it for C, well, we also knew that when we say C squared plus d squared equals e squared. So that's what I'm visualizing. We have the smaller triangle. It was a 3, 4, 5 triangle, but it was, if we're assuming A, B, and C. But then if you take that C, and we're saying the height is the D, and we're trying to find E, that's the bigger triangle. So I just wrote it for two different things. Now here's the thing. We're ultimately trying to find E squared. So we know that C squared is equal to this. So we could replace C squared with that. I hope you're following so far. Because that's what A squared and plus B squared is equal to C squared. So let's just replace it and say A squared plus B squared plus D squared. And the thing that I changed was the C squared. I changed it to A squared plus B squared equals E squared. Now that looks crazy. I know, I think that looks a little crazy, but this part right here was just replaced. I just replaced C squared with that. So then finally, if you want to get E of all by itself, you take the square root of the whole thing. So I would end up with E is equal to A squared plus B squared plus C squared, but the square root of all of that. So if you knew all those values, you could do it in one fell swoop. But you don't have to. You can do it the exact way we did it up here, and we did the Pythagorean Theorem twice. It's less confusion, I think, when you do it that way. Okay? So what I'd like you to try on your own is number 13. It says find the length of the diagonal from P to Q. So it's going from here to here. So that little dotted line went across there. And again, if you wanted to make a right angle, you'd have to find this diagonal that would form with it, because we have the height is 8, but we don't know what that other leg is. But you can use the 9 and the 12 to find it. So I'm going to give you a second. Why don't you pause it and try it? Pause and try, pause and try. Pause the video and try it on your own. And then you can unpause it and take a look at how I did it. Did you pause it? Try it? Told you to. If not, you should pause it and try it. If you did, I'm going to go through it right now. All right, so I want to find this diagonal first, because I need that in order to find my side PQ. So we'll say in this triangle right here, we have 9 squared plus 12 squared equals, and we'll say this is our C squared. Now you might know 9, 12, and 15 is actually a Pythagorean triple, but let's double check it. That's 81 here. That's 144 here. Those two add together. Do it on a calculator. You get 225. 225 equals C squared. Square root of 225. C does equal 25. Okay, that's not our final answer. We're trying to find this length, this dotted line. But now we know, and I'm going to pull this triangle out. I'm going to say I have this C, and then the dotted line goes across like this. We're trying to find the dotted line. My dotted line is getting really weird. But we have this as 8, and we found this C, which is 25. And let's just say our diagonal is D. I don't know. So let's take this, has to be a right angle because it's a rectangular prism still. So 8 squared plus 25 squared, those are the two legs, equals D squared, which is our hypotenuse. And let's figure it out. We figured out before 25 squared, because it's opposite of what we did. It should be 220, not 25, 15. Why did I write 25? I apologize. I meant 15. This should be 15. 15 squared is 225. And I know 8 squared is 8 times 8 is 64. Add those together, and 280, 289. You just got to figure out the square root of 289, and you got your length. I'm going to guess it's 17. Pretty sure it's 17. I got it. It is 17. The square root of 289 is 17. So our length that we're trying to find is 17 units. And that's our study of the Pythagorean theorem within three-dimensional figures. I hope you learned something here today. Hope you're continuing to get stronger with using the Pythagorean theorem. And today was specifically using it with applying it with 3D figures. Have a great rest of your day. Hope you learned something. See you next time.